Hello everybody! Have you ever wanted to experiment with electronic circuits but found the idea of soldering a bit intimidating? Well, fear not. Today we are going to discuss about a component which will help you build electronic circuits without soldering or damaging your components. It is called a breadboard. In this video we'll understand how a breadboard works, what are the types of breadboards available in the market, and what is the history behind these breadboards. But first, before starting, let's discuss why do we even call it a breadboard? It is not that we have mixed a bread and a board to make it a breadboard. Of course not. Then why do we call it a breadboard? Well, the answer to it dates back to early days of electronics, when the engineers used to drive nails on these wooden boards to make the circuits. And on these wooden boards, it was actually used to cut bread at that time. So the name breadboard. A breadboard might look like a grid of random holes, but each of these holes is connected to the other hole in a very specific way. By plugging wires and components on the right hole, you can create all kinds of electronic circuits, from a very simple LED glowing circuit to a very complicated microcontroller project. But to understand how a breadboard actually works, let's take an example. Let's take the example of a water flowing through an individual building and through a series of buildings. So in the first case of an individual building, we normally see a water tank on the top and a water tank on the bottom, where the pump pushes the water from bottom to top. And we use gravity to make the water flow to different floors, right? So the water is flowing top to bottom and bottom to top. That the same thing is happening on our breadboard as well. In the middle section, electricity flowing from top to bottom, bottom to top, again from top to bottom and bottom to top in this middle section. But keep a note, it is not flowing in the middle channel. This is a separate channel and this is a separate channel. Again, top to bottom in the two separate channels. Now let's take the other example where water is flowing horizontally from the tank to all the buildings. The same thing is happening on our breadboard as well, where the top section and the bottom section, electricity is flowing left to right and right to left in the horizontal direction, right? But here comes the point. How does the breadboard actually know from which direction to which direction the electricity should flow? Should it go from left to right or right to left? Or should it go from top to bottom or bottom to top? The secret lies behind the breadboard. So if you turn around the breadboard and remove the double-sided tape, you'll see these metal strips. This is where the actual magic is happening. These metal strips, and mind you, metals are good conductor of electricity. So these metal strips are allowing electricity to flow from top to bottom and from left to right. So this is the secret of our breadboard. And one thing to note here, that these horizontal lines and these vertical lines are not connected in between. Same is the case here in the middle and same is the case here in the bottom. So we make a circuit from top to bottom to a vertical line to another vertical line and connect it to a horizontal line below, and a complete circuit is made. So let's take an example here and understand our concept of breadboard even better. Let's take point number 1, point number 2 and point number 3. If I give electricity on point number 1, will I get the same electricity on point number 2 and point number 3? If your answer is no for point number 2 and yes for point number 3, you are correct. Why? Because as we have seen in the previous slide, there's a metal strip connecting point number 1 and 3. But the metal strip on top is not connecting point number 1 and 2. That is why electricity is flowing between point number 1 and 3, but not between point number 1 and 2. Let's take another example. This be a point number 1, this be a point number 2, this be a point number 3 and this be a point number 4. Same question. If I give electricity on point number 1, will I get the same electricity on point number 2, 3 and 4? If it's yes for point number 2 and no for point number 3 and 4, you are correct. Why? Again, there's a metal strip connecting point number 1 and 2, but there's no metal strip between point number 1 and 3 and between 1 and 4. And as I have said before, the middle section does not allow electricity to flow between the two sections. So point number 1 and 4 are separate from each other, right? Now that you have understood how the breadboard actually works, let's see what are the types of breadboards available in the market. Here we see this is a 180 point breadboard. These are small breadboards used to make very minor projects. Then there are 400 point breadboard, which are generally used to make medium sized projects. And then there's a third type, which is this 800 point breadboard, which are larger in size and allows you to make bigger projects. But the best part about these breadboards are that if your project is not fitting on one single breadboard, you can join one breadboard with another one using these clips given on the sides. So you can connect these breadboards in a series and make a bigger project area for yourself. So that's a brief overview of what are breadboards and how they actually work. It's a very versatile tool that allows you to experiment with electronic circuits by plugging wires and components into very specific holes and creating a path for the electricity to flow through the circuit. In this video, we have covered the basics and concepts behind the breadboard, and in the next video, we'll dive into more details and create our first project using this breadboard. Thank you for watching, guys. Keep learning and keep having fun.